2100. True course measurements on a sectional aeronautical chart should be made at a meridian near the midpoint of the course because the a. Values of isogonic lines change from point to point. b. Angles formed by isogonic lines and lines of latitude vary from point to point. c. Angles formed by lines of longitude and the course line vary from point to point. The correct answer is C. When measuring true course on a sectional aeronautical chart, it is important to consider that the angles formed by lines of longitude and the course line will vary from point to point. This is because lines of longitude converge towards the poles, resulting in a distortion of angles as you move away from the meridian near the midpoint of the course. Isogonic lines, which represent lines of equal magnetic variation, can change from point to point on the chart, but they are not directly relevant to the measurement of true course. Similarly, the angles formed by isogonic lines and lines of latitude may vary from point to point, but they are not the primary factor to consider when measuring true course. Therefore, the most accurate measurements of true course on a sectional aeronautical chart should be made at a meridian near the midpoint of the course to minimize the variations caused by the convergence of lines of longitude. 3814. What procedure is recommended when climbing or descending VFR on an airway? A. Execute gentle banks, left and right for continuous visual scanning of the airspace. B. Advise the nearest FSS of the altitude changes. C. Fly away from the center line of the airway before changing altitude. The correct answer is A. When climbing or descending VFR on an airway, the recommended procedure is to execute gentle banks, left and right, for continuous visual scanning of the airspace. This technique helps maintain situational awareness and allows for better visibility of other aircraft and potential obstacles in the vicinity. By making gentle turns, you can increase your field of view and enhance your ability to detect and avoid any conflicting traffic. Executing gentle banks helps you to scan the airspace more effectively and reduces the risk of colliding with other aircraft. It allows you to maintain visual contact with surrounding traffic and provides an additional layer of safety during the climb or descent on an airway. This procedure is important because it helps ensure that you are aware of your surroundings and can react promptly to any potential conflicts or hazards. It is crucial to maintain vigilance and continuously scan the airspace to maintain safety during the climb or descent on an airway. Therefore, the recommended procedure when climbing or descending VFR on an airway is to execute gentle banks, left and right, for continuous visual scanning of the airspace. 3598-1. When the course deviation indicator, CDI, needle is during an omni-receiver check using a VOR test signal, VOT. The omni-bearing selector, OBS, and the TO from indicator should read A. 1800 from, only if the pilot is due north of the VOT. B. 0 degrees TO or 180 degrees from, regardless of the pilot's position from the VOT. C. 0 degrees from or 180 degrees to, regardless of the pilot's from the VOT. The correct answer is C. During an omni-receiver check using a VOR test signal, VOT, the course deviation indicator, CDI, needle should be centered, and the omni-bearing selector, OBS, and the TO from indicator should read 0 degrees from or 180 degrees to, regardless of the pilot's position from the VOT. The purpose of the VOT is to provide a known reference signal for testing the accuracy of the VOR receiver. When the CDI needle is centered during the VOT check, it indicates that the receiver is properly aligned with the VOT signal. The OBS should be set to the radial that corresponds to the VOT signal, which is typically 0 degrees. The TO from indicator, in this case, should read 0 degrees from or 180 degrees to. This is because the VOT signal is considered to be from the station, and the receiver is receiving the signal in the to mode. It's important to note that the correct indications during the VOT check are independent of the pilot's position from the VOT. The purpose of the check is to verify the receiver's accuracy and alignment, rather than the pilot's position relative to the VOT. 3598-3. If receiver autonomous integrity monitoring, or AIM, capability is lost in flight. A. The pilot may still rely on GPS-derived altitude for vertical information. B. The pilot has no assurance of the accuracy of the GPS position. C. GPS position is reliable provided at least 3 GPS satellites are available. The correct answer is B. If receiver autonomous integrity monitoring, or AIM, capability is lost in flight, the pilot has no assurance of the accuracy of the GPS position. RAIM is a feature of GPS receivers that provides an integrity check on the GPS signals received. It ensures that the GPS signals are accurate and reliable for navigation. If the RAIM capability is lost, it means that the GPS receiver is unable to verify the integrity of the GPS signals it receives. Without RAIM, the pilot cannot be certain of the accuracy of the GPS position. Other factors such as satellite availability, signal strength, and potential errors in the GPS system can affect the reliability of the GPS position. 3598-4. How many global positioning system, GPS, satellites are required to yield a three-dimensional position, latitude, longitude, and altitude, and time solution? A5, B6, C4. The correct answer is C. Obtain a three-dimensional position, latitude, longitude, and altitude, and time solution using the Global Positioning System, GPS. A minimum of 4 satellites is required. Here's a more detailed GPS is a satellite-based navigation system that consists of a network of orbiting satellites, ground-based control stations, and GPS receivers. The GPS satellites continuously transmit signals that include information about their location and the precise time the signals were transmitted. To determine its position, a GPS receiver needs to receive signals from multiple satellites. The receiver measures the time it takes for the signals to reach it from each satellite and uses that information to calculate the distance between the receiver and each satellite. By receiving signals from at least 4 satellites, the GPS receiver can then use a process called trilateration to determine its precise position in three-dimensional space. Trilateration involves intersecting spheres or sphere surfaces, where each sphere represents the distance from a satellite. The intersection points of the spheres determine the receiver's position. Additionally, the signals from the satellites contain data that allows the GPS receiver to calculate its altitude. This altitude information, along with the latitude, longitude, and time, completes the three-dimensional position and time solution. It's important to note that having signals from more than 4 satellites can improve the accuracy and reliability of the GPS position calculation. However, a minimum of 4 satellites is required for a basic three-dimensional position and time solution.